Hey everybody, and welcome to another video series from the Electronic Armory. In this series, we'll be building a complete iOS application from start to finish using a number of technologies such as core data, GPS, core location, loading data from web services, getting images from the camera, notification center, table views, CocoaPods, and so much more. I have previous videos on all these things if you need more in-depth explanation of any of them. We'll also discuss architecture decisions, how to pass information between view controllers and the rest of the application. We'll also talk about some important concepts in application development, refactoring, singletons, factories, observer patterns, and data models. This will be a multi-part series, and at the end, we should have something very close to a completed application. There's a lot to cover, we'll go quickly, but you can pause and rewind as needed, and we'll be posting the example code via GitHub repository below. Be sure to comment if you have questions, share it amongst your friends, and join the Discord channel if you have questions that you want to get answered by me or somebody from the community. So let's get started. All right, we're going to start off with a single view application in Xcode. So I'm just going to hit next here, and I'm going to name this rock climbing. This is going to be a rock climbing application that we're going to have different locations, images of the different rocks and places to climb, and as well as different metadata and things like that. But certainly this can apply to any type of application. We're just going to use this as an example. So the first thing I'm going to do is make sure our user interface is Swift, not Swift UI, but storyboards. We'll cover Swift UI in a future video. And the other thing is we're going to use core data, as I mentioned before. Now you can use CloudKit, which will store your core data files up in the cloud so that you can sync those pieces of data between the different devices that you have. But for right now, we're going to leave that unchecked. Great, I'm going to navigate to where I want to save the project and go ahead and hit create. Now we can create the Git repository right here and now. Let's go ahead and do that. All right, and we're all set up. First thing I want to do is look at the settings for my project. I'm going to turn off landscape left and landscape right so that when we rotate the device, it doesn't try to rotate it. And then as soon as we do that, I'm going to actually close this. Now just a little bit of an explanation of what we're going to do. So this is kind of what I want to have in an application. So here is what we call a crag, this area of rock here. And then each one of these lines represents an actual climb. And so these climbs have different ratings and different notes, and you can see that there's different routes to take on those. And we want to set up our data model so that we can easily use that in our application, because if we change our data model later, it's going to affect the entire application, how that data is presented. So we want to get this right the first time. Okay, the next thing I want to do is actually set up CocoaPods. So if you remember from a previous video, I'm going to navigate to our rock climbing directory that we have our Xcode project in. And this one is in a subdirectory, so I'll just go ahead and change directory to that one as well. And here is our Xcode project. So at the root of our project, where the Xcode proj file is, we're just going to type in pod and then init for initialize. Hit enter on that, wait a second or two, and then it will create a new file called pod file. Now the thing that we want to do for this one is we're going to include things like Alamo Fire and a number of other libraries that we're going to be using in our finished application. So for right now this is okay, but what I'm going to do now is just hit pod install. We don't currently have any CocoaPods installed, but this will create our workspace. So I'm going to hit enter on that one. And it did its thing, and then if I list the directory again, you can now see that we have an Xcode workspace project, and this is what we'll be using going forward. I can just hit type in open and then period for current directory, and then give it a second and it'll open up a Finder window. So now we have this Finder window open. I can double click on the workspace project, and we will not be opening the Xcode project from now on. So again, just using the Xcode workspace file. And that's because the workspace will include the different projects from CocoaPods and whatever else we want to include, such as frameworks. So you can see all our pod files here, the number of frameworks. We don't currently have any, but then we have our original rock climbing project here. So again, if you want more details on that, there's a previous video on CocoaPods. All right, so the first thing we want to do is set up our data model. So I'm going to click on rockclimbing.xcode Xcode data model ID. And this is going to be a list of our entities. Now, entities are our actual objects that we're going to have persist throughout our application in core data. So if you're not familiar with that, I have a whole video on core data that I'll link to in the description below. But for right now, we're just going to start adding the data that we need. So the first thing that we need is to add an entity. So down here in the bottom left-hand corner, I'm going to click on Add Entity, and it's going to create an entity with the default name of entity. So you can double click on that, or you can edit it over here on the right-hand side. And I'm going to call this Crag, because this is going to be our Crag area. And the Crag area is going to have a name, so I'm just going to say Crag name. Hit plus under here to add another attribute, and these attributes are attached to our entities. And so the Crag name, it could have some notes about it, so Crag notes, and both of these are going to be strings. And of course we have all sorts of different data types that we can choose from, such as double, float, etc. But we're going to choose string in this case. And then also for notes, and we'd be able to add notes. If I go back to our example here, there's some Crag features. Maybe we add an attribute for Crag features, and maybe some approach notes if we want to. But again, the data that is represented under each one of those attributes would be just a string. A pretty long string, but there you have it. So the next thing that we would want to do, and we'll do this in a future video, is actually add an image such as this. But again, we'll add that in a future video when we get into adding, taking photos from the camera and adding it to our data model. All right, so we have the Crag name, the Crag notes. We can always add attributes later. Again, we want to try to get this right the first time, but for right now, in terms of simplicity, we're just going to keep it this way. I'm going to add another attribute, and this one's going to be called a route. So usually with Cocoa Touch, we don't want to necessarily keep very short names such as route, because route might actually be in conflict with another class name that Apple's already defined. So I like to stay away from those short names that may or may not have conflict with that, such as routes, because that might mean something else. I'm going to call this climbing route just to be a little bit more explicit. And go back to select climbing route. And then we're going to add some attributes here by hitting the plus key. And this one is going to have, I can call this route name, hit enter. And then if we go back to our data here, you can see that each route or climb has a name. It has whatever somebody named it. It has the difficulty or the grade, and you have a couple other ones on here as well. So if we go back, we're going to simply use the same attributes that we used before. So route notes. And then for the difficulty, I'm going to actually separate this out into two settings, because we're going to use a type of difficulty scale. And this scale is a numeric value plus sometimes a letter. So for example, it could be 5.7a, 5.7b, 5.10, B, etc. So we're going to first put this out as a route difficulty. And then the other attribute we're going to break that out into is route difficulty. And then I'm just going to put sub for sub difficulty. You can name it whatever you want, but this is what we're going to do. So the notes here, I'm going to set these to a string. The name is also a string. And the route difficulty, as I mentioned, is going to be 5.7, 5.10, 5.9, anywhere in between, even 5.11. It goes up all the way up to 14, I believe. But we're not going to put those as doubles. Instead, we're just going to keep it as a string. We don't really need to do any numeric operations on this. And so we're just going to keep it simple and do it as a string. And then for the route difficulty sub, this is also a string. It's going to be a single character. And we can set that as a string. Now for the route name, if you go back to our core data video, you can see that there is going to be a default value. We can set it to be optional, but I don't want a route in our system that doesn't have a name. So I'm going to uncheck optional, and then we can add in a default value if we so choose. And so if we do not set the route name, this value will be placed for any object that we try to insert into our database that doesn't have a name. And so that might be useful for you. Now the route difficulty, as I said, is a 5.7 something, a 5.10. So we can turn off optional there. And let's say just by default, it's a 5.7 if you don't enter that in. And the sub difficulty here, if it doesn't show up, just select it again. Sometimes it has a little bug. So right now it's showing the entity and not the attribute. So unselect it and then select it again. Sometimes you have to click around. There we go. So now we have the attribute on the right-hand side. And actually I want the sub version. There we go. And this is optional. Sometimes it's just a 5.7, sometimes it's just a 5.8, etc. So that's okay if we leave that blank for right now. All right, so the next thing we do is when we go back to our example, the purpose of this application is to help find a Crag and then also help find these routes. So this is really nice to have an image of it, but what if it's a really long or wide wall? We might need to find these routes by GPS location. Certainly we'll need to find the Crag by GPS location so we can show it on a map, and we'll handle that as well in a future video. But each one of these crags, or this rock area with all these different climbing routes on it, will need a GPS location. So let's set that up in core data. We're going to set that up as another entity. And if I go down here to the bottom right hand corner where it says editor style and click on these three boxes, we can now see our entities more in a graph view. All right, so these are just independent entities. They're not connected to anything else. But we're going to go ahead and change that. So I'll show you how to add it via this view. Same thing, go down bottom left-hand corner, hit add entity. And we have this new entity. We can either change it here on the left-hand side or over here on the right. And we're just going to call this climbing location. Again, I don't want to call it location because that might conflict with the core location data types. All right, so we have climbing location here, and then we can add in attributes. So I'm going to go bottom right hand corner, add attributes. It added it for the Crag because it was selected, so that's a small bug in Xcode, so I'm just going to go ahead and delete that. Make sure that location, climbing location is selected, and then re-add the attribute, and now you should see it there. All right, so now we have this one. And for this one, I'm going to type in latitude, and then I'm going to add another attribute. Make sure it's in our climbing location, and this one's going to be called longitude. Neither one of these should be optional. All right, so let's go back to the grid editor here. And we're going to change these. So latitude is going to be a double precision floating value, which is what the core location data types are. So we're just going to match those up. And then also we have altitude for GPS. So GPS points have a number of pieces of data associated with it, namely latitude and longitude, which you're familiar with, but also altitude, excuse me. And altitude is going to be, I do believe it's another double. It might be an integer. We can double check on that and we can change it later if we need to. All right, so we have our altitude, longitude, and latitude. If we go back to our graph, you can see now what I want to have is a relationship between the Crag and climbing location, because we want to associate Crag with climbing location, but also routes might have climbing locations as well. And that's why I broke it into a third object rather than putting latitude, longitude inside a Crag and then duplicating those pieces of data to climbing route as well, namely latitude and longitude. So I didn't want to have latitude and longitude between these two entities, Crag and climbing route. All right, so how do we get Crag to point to climbing location? Well, for that one, we add a relationship. So I'm going to go back to this style of editor, and under relationships, we're going to hit the plus key, and we're going to call this relationship. This is on, this was the wrong one. Let me go ahead and delete that. And then under Crag, hit the plus key under Crag, and this one's just going to be called Crag location. And the reason why I'm prepending all of these attribute names and relationship names with Crag is so that when I type in Crag, our autocomplete, when it pops up, will show all of the members here that I can select, and it just keeps it organized for me. All right, and so we set the Crag location, but we need to set the destination. So if we go back to the editor really quickly, we can now see in our object here, this Crag object, we have an item under relationships. So I'm going to change the destination to climbing location. Now if we go back to the graph, you can see that there is a arrow with a line with an arrow, and it's a single arrow. Now if Crags had multiple locations for some reason, then on this relationship value, there we go, we can do type one to many, and that will put in a double arrow. But right now we don't have any data that is one to many. And well, basically what that represents, if you're curious and you're trying to make your own data model, is that Crags could have multiple climbing locations, and that would basically be represented as an array. Technically it's a set, but you can think about it as an array for right now anyway. So we're going to change this back. I guess if you double click on it, it'll change that. We're going to change the type from one to many to one to one. All right, and we also have things like delete rules. If I delete a location, does it go back and delete the parent object as well? So we won't get too much into that right now, but for the climbing route, we also want to have a relationship for the location. So route location, and then the destination is to our climbing location. So this is a way to have data attributes that are of a more complex type, such as a GPS location, rather than just making integers or doubles or whatever you have the types up in here. All right, so let's go back to our graph really quickly, and now we can see that our climbing route has a location and our Crag has a location. But for Crag, we want to actually associate all of these climbing routes that we're going to create in our database back to our Crag. And so Crags can have multiple climbing routes. So we're going to create a relationship from Crag to many different climbing routes. So if we go back to our example, you can see that this Crag here actually has, 5 different climbing routes. So red, orange, yellow, green, and blue. All right, so the way that we do that is pretty much the same as we go back to our graph. This is my preferred way of editing this. But if you did want to add it via the graph here, once your Crag is selected, go down to, instead of add attribute, click and hold, and you can have add relationship. We also have fetch properties, which are a little bit more complicated, but now we have a new relationship. I'm going to double click on that, change it here, and we're just going to call these climbing routes. Starts with a lowercase letter, and then I'm also going to add an S at the end to denote that it is going to be a one-to-many relationship. All right, so once that's selected, we're going to go again to many, and this is going to change it from a single climbing route entity to a bunch of, or a collection of climbing routes. All right, so we haven't set up that relationship or that destination yet, so we're going to set from Crag to climbing route, and there we go. So now we have our multiple one-to-many relationship. But it might be useful if we are looking for different climbs of different difficulties. So let's say I'm a beginner climber. The easiest route is going to be a 5-7. The hardest, one of the hardest anyway, is going to be a 5-10, 5-11, etc. So what I might want to do is search my database for all of the 5-7s and then link back to the Crags that exists for those. So for example, I might have a list of all the 5-7 routes in my area, but where are those routes located? Well, they're located at different Crags. So I need a relationship from climbing route back to Crag. So I'm going to have climbing route selected, go down and add a relationship. Right now this is currently selected as relationship, so I can just click, it'll add a relationship, and then double click on that to get inside of it. And then we're going to say, instead of relationship, this is going to be, just call it Crag. Now this relationship is a 2-1, so a climbing route can only have, or can only be in one Crag. So this is going to stay 2-1 relationship. So a climbing route is going to go 2-1 Crag. And again, if you want more details, I have a video on that. So we're going to stop there and move along. The destination for this relationship is going to go back to Crag. So up in the top right hand corner under destination, select Crag, and now we have this crisscrossing of lines. But we're going to fix this because this isn't a separate relationship. This is actually a relationship back and forth. So with Crag, double click on that to select it, we can do a inverse relationship back to climbing routes. And you can only see this once there is a relationship going back and forth from one entity to the other and vice versa. So if you don't see that, you don't have the relationships from Crag to climbing route and from climbing route to Crag. And once you have that set up, now I can do the inverse. So now you can see that this is a one-to-many relationship. Now I'll show you how to use that via code here in a few minutes. All right, so that's our basic data model for right now. We're not going to get too complex for right now. We'll add some more entities as we need them later on. But for right now, we're going to go into our app delegate file. And if you scroll down, you can see, or if you look on the right-hand side here, we have these core data stack functions here. And this is what we will use to talk to core data and the persistent store coordinator, which is going to store our actual data. So what I'm going to actually do, instead of keeping this in my app delegate, which it should not be in because it's not a delegate method or anything like that, we're going to cut all of this out. So Command X to cut that out. And then under rock climbing folder, we're going to add a new file, and we're going to simply call this. For this one, we're going to call database controller. And put it into our source file folder. And we have this guy here. So what I'm going to do now is simply paste this in. And it's going to complain first off of the persistence coordinator. It doesn't know what that is. So I'm going to go back to the app delegate, and you can see that we imported the module of core data. So I'm actually going to take that out because we don't need it in the app delegate. And I'm going to put it into the database here, the database controller. All right, that's not going to solve our problem for all these other issues, but for right now, this is pretty good. I want to actually create this class as a static class that we can access from anywhere. And so if we wanted to just call database controller.save context in order to save our database and persist whatever changes we've made, then I'm going to call that. But this needs to be either a static function or a class function. I'm going to make it a static function. And then for this variable, the lazy var basically means that this will get instantiated when we first try to access it. So it'll be a lazy load if you're familiar with that concept. But this is not going to work the way that I have it here, because what it's doing is it's expecting that because this is a static function, that the persistent store coordinator here is also going to be a static member that we can use. So we have to make a few changes. All right, so as I mentioned, we're going to change this persistent container from a lazy variable to a static variable. And we're not going to have the initializer here, but what we're going to do instead is create a function that is going to give us access to this. So this one is going to be, well, let's make this a static function as well. If we made it a class function, we could subclass it if we wanted to, but we're never going to subclass database controller, so we'll just make it a static. And then, so this one we're going to simply just call it the manage object context. This is going to be a function, and it's going to return the NS persistent container that we've defined in the line above. So NS persistent container. There we go. And then we're going to start the function declaration here. And first off, what we're going to do is we get this error here real quick, and this is just letting us know that this is not, we don't have an initializer for this. So we're going to make it an optional and set it to nil. And then when we first access this, we're going to set it to a value. So if the value of this is equal to nil, meaning it hasn't been instantiated yet, we're going to go ahead and inside here instantiate it. And we don't need to do the return value of it anymore, but instead we're actually going to return this as part of this function. So this is just set up as part of the lazy variable initializer. So we could still do that here if we wanted to, but just to kind of show you what this, how we would kind of refactor some of this stuff is I would just make sure that we have all of our parentheses and curly braces set up. So if it's nil, what we're going to do is fall inside of this if statement. We're going to instantiate the container, this local variable called container, with a persistent store coordinator named rock climbing. And so we can change the name of the file that gets created for our database. The other thing is we're going to change this from a local variable to our static container here. And get rid of this let declaration. And then also make sure that we have a ending curly brace for all of our objects. So we're going to line up this one. Let's see, get rid of this thing, and I'll post all this code to the Git repository. So if you don't want to go through this, you can just download the database controller file that I have set up and make sure that we have matching curly braces for all of our objects. So after the if statement, we're going to return this, and now everything should be good here. But because this is an optional, we have to unwrap it. But I know that it's wrapped inside this nil check, and so I know that that's going to be a not nil. Oh, and then one more issue is that we changed it from a local variable to a class variable, so we just changed that name. All right, then it's expecting an end parenthesis there, but in fact we're going to refactor this, and instead of making this, this will just be a closure here, and this closure will define this persistent store. So basically load in this guy and set it to this one, so that it'll load the file in and everything that core data does under the hood there. And again, with our container, I should have just renamed that, but we're going to rename that as well there. And of course, unwrap it. All right, so I'll leave that on the screen for about 3 seconds so you can copy it down, pause the video, and we'll move on. All right, so then the next thing we have to do under that one is change our save context, because again, we're using this persistent container, but this needs to be this is an optional, so we need to unwrap it. However, if we try to save the context before loading in the context, then what's going to happen is it's going to be nil, and this view context is not going to work. It's basically going to crash if we forced unwrap it, I should say. All right, so if our persistent container hasn't been initialized yet, what we would really like to do is have that lazy initializer set up for us, but in this case we don't. So I'm just going to do a quick nil check on this, and instead of doing a nil check and just saying if it's equal to nil, what I can do is I can do an if and then let, and this if let will allow us to basically do a nil check, but also create this local variable as well. So I'm going to indent this to make sure we have all of our curly braces. This check in here, basically, if you have changes to this, it'll go ahead and try to save it. Well, I've put this in so we can use context only within the scope of this if statement. And so this if let is a nice check for us to do a nil check and then use that resulting value within our if statement for, I don't basically have to unwrap any of this. What I do have to do is make sure that this is going to be unwrapped. So I'm using an optional unwrapping here. So what will happen is if this is nil, then this will return false, or excuse me, it'll return nil, and then our if will fail and then drop down to here and basically do nothing. And so we might do some error handling here, but I'm going to make sure that our persistent store coordinator is set up before anything gets called. So I'm going to call manage object context up in our did finish launching with options. And so this is one of the first ways that we can access any information in the application. So it's kind of like our main function, but what we can do now is database controller dot manage object context and just call that, and it's going to return it, but we don't really care. We just want to go ahead and just call that function. And so basically what we can do is set this equal to an unnamed variable, and that'll get rid of that warning. And so it's saying, yes, we are returning a value. You're not storing that value anywhere, but I'm just going to say, yep, I know, and I'm going to put it into a name value. So you might not want to do it this way, but I'm just illustrating the fact that we can call that, and one way of getting rid of that warning. Okay, so we know the first thing our application is going to do is load in that database file. All right, so let's get some data in our database and start displaying it. The first thing I'm going to do is create a table view in order to show the data that we're going to be entering. Now I'm going to hard code all this data for now. In future videos, again, this is going to be quite a long series, is I'm going to put that data into a spreadsheet, create an application to parse it, put it into its own data file, take that SQLite file that's in our database, that represents our database, and then include it in as part of our project for default data that the user can basically allow them to look at upon opening the application. They don't have to enter in their own data. So I'll show you how to do that. But for right now, we're going to put in a table. So I'm going to hit the plus over here. I'm just going to type in table. Now this is our default view controller that we have, and I'm not going to use a table view controller because that's very limited in what we can do with the table view. So I'm going to take table view, click and drag, drop it in here, and then resize it to fill up basically the entire part of our screen. With a table view, it kind of will go to the far left and far right of our window, or excuse me, our view, and just drag it to the margin helpers here. So we do, if we did want a little bit of a margin, we can see that we have our blueprint type guides here, but I'm going to hold down Control, click, drag up, and I'm going to say top space, holding down Shift, and then holding down, continue to hold down Shift, bottom, leading, and trailing, and that will go ahead and set up our constraints. So as our view expands or shrinks, it'll always fill up the entire part of our screen. I'm going to hit enter or return. And now we have our table view, and we can test that to make sure I got all the constraints by clicking in the bottom here and going up to iPad. So iPad is huge, and it also takes up the entire screen on the iPad, but it doesn't go off the screen. And we can go down to a 4S, and that looks pretty good as well. So I'm going to go back to whatever device this was, iPhone 8. That looks pretty good. Or we can go to the newer devices such as the 10R, oh excuse me, the 11 Pro Max. It's probably a little bit too big for my screen. Yeah, let's just keep it at the iPhone 11 Pro, so it just fits on my screen here. All right, so the first thing we're going to do, you can set up our table view. We're going to go through this quickly. Again, I have a whole video series on table views, etc. So we're going to go prototype cell. I'm going to add one type of cell for this one. This is just going to be a list of Crags that we have. And the prototype cell, that's all we're going to do, but we are going to select it and give it a reuse identifier. So this one I'm just going to call Crag cell to keep it different from a route cell, which is going to look a little bit different. I'm going to copy that. And then I'm going to go over to our view controller. Now there's no delegate methods in here yet, but before we do that, we're going to set up our table view. I'm just going to type in some letters and then delegate, and that comes up, and then we're going to type in table and then data, and then the data source UI table view data source should show up. There we go. And then under here, now we have the ability to get our data source and delegate methods. So namely what I want to do is the number of rows. So I'm going to type in number of rows, and you can see that that's the first one that pops up. Hit enter and it will replace what I typed in with the actual code. And for this one, we're going to type in a return value. Now we don't actually have a list of Crags just yet, so we'll get there in a second. But for right now, I'm going to test to make sure my table view works. And then the next thing we're going to do is table view cell for row. Okay, so table view cell for row, it's going to pass in an index path. So right now I'm just going to have a variable here, a constant variable, let variable, and we're going to call this cell, and it is going to equal or set it to equal or table view.dequeue cell for reusable cell with the identifier, and guess what, we're going to use that identifier right there. All right, so before I forget, I'm going to return the cell, get rid of some of those warnings, and also the return value on this dequeue cell. If I click somewhere in here and hit escape, you can see that the return value is an optional. So first we'll want to make sure that we that this is indeed passing some kind of value back. What dequeue reusable cell will do if no cell actually exists is it will create one for you. So that's really nice, but it is an optional. It could come back as nil. So we want to make sure that that is do a nil check before. So we could even wrap this in an if let cell and then return this as a condition of that if statement. There, and just for testing purposes, we're going to set the text label .text to just test. All right, and then finally, I should have done this before, but going back to our main storyboard for our UI table, I'm going to control click and then drag it up to our controller and set the data source and the delegate. However, you can also do it from the hierarchy view here. So control click up to the view controller on the top left-hand corner, and then set the data source and the delegate either that way. So whichever way you prefer. You can do it from the left-hand side or you can do it from your view. All right, so let's go ahead and test this, make sure everything works. I think there were going to be an error first though. Yep, so we forgot one more thing when we did refactored our code. So when the scene does enter the background, we might want to save any changes to our database that hasn't been persisted yet to our database. And so if we did not put it into our database controller, this would be how you would save the context. And this is kind of messy, right? We get the application, we get the shared instance of it, we get the delegate, we typecast it as the app delegate file, which comes from this file name up here, and then finally we do the save context. So the reason I put it into the database controller is now I can just say database controller save context. All right, and then we did forget to unwrap that. Now let's test out our application. Right, so we have 5 different rows and they're just saying test. Now let's go ahead and add some basic data in here, and we'll show you how to delete that data and basically how to do everything that we would do when we're actually creating an application. So really quickly, when our view loads, what we're going to do is just create a Crag. So Crag object, I'm just going to say let new Crag equal, and then what we're going to do is use the constructor. Now the constructor for this guy is going to be, we're going to need to have the manage object context being passed in. And again, where does that manage object context come from? It's our database controller and then manage object context. However, this is the persistent store, so I should rename this, but I'll do that in a second. To this is our actual manage object context, which you can see here, ns manage object context. This is the return value for this function call or for this member accessor. So I kind of named this So I named this wrong kind of on purpose. It used to be called manage object context, but let's go ahead and rename this really quickly. I kind of left it to show you this, but this is the value of it. And again, it's returning a persistent container. So I'm going to right click on this object, go down to refactor and rename. And for this one, I'm going to call it persistent store container. Hit enter on that one. And it should name it throughout the entire use of your wherever it uses it within your application. All right, so we have this new Crag object, and for some reason, if you don't see Crag come up, like if the autocomplete doesn't work, go ahead and actually restart Xcode. There was a previous bug. I think it's fixed now, but in previous versions, there was a bug where it actually didn't create the class files behind the scenes. So if you have any problems with that, either ask in the comments below, jump on the Discord channel and ask, and we'll get you set up there. But this should work now with the latest version of Xcode 11. All right, so now we have this new Crag variable, and we can just start using it just as it was a normal class. And so we have Crag. I'm just going to type in Crag. And so the reason I did that was because we have Crag name, Crag notes, and Crag location, and those are all going to be variables at the top. So we're going to set Crag location to new Crag location, and then type in Crag again, notes, and these are just going to be some, here, etc., etc. In order to set up location, new Crag.Crag location, this one is going to expect a Crag or a climbing location. And so we have to basically do the same thing there, as we have to create a climbing location object using the constructor, passing in the manage object context, and then database controller, persistent store container, select the right one, view context. But this can get quite verbose, so I'm going to pull this out, and up here we're just going to have a let variable called context and replace all instances of this with that, because if we need to call that a bunch of times, it could get pretty annoying. So anyway, all right, so we have a new location here, and we're setting it to this location. And if you want to, you could break this object out into its own line of code and then start editing here, or you can do it here as well. So latitude and longitude, and we're just going to make stuff up here. I will show you in another video how to actually get these actual GPS locations. If you don't have an app that does it for you, you can look it up via Google Maps, and then you can get the GPS location from there, and then put it into an Excel spreadsheet and then import it. But again, that'll be a different video. So I'm just going to start making stuff up here. This is a double precision value. Something like that. I don't know, those don't exist, but that's okay. And that's how we create an instance in our database, but we haven't actually saved it. Now, if we backgrounded the application, we could save it, but I'm going to go ahead and save it here. Database controller, save context, and that will save it. And so every time we launch the application, it'll go ahead and create a new Crag, put that into our database with a Crag location, and then also what we'll do is pull that data out. So let's go ahead and do that really quickly. Now, normally you wouldn't do it all in the ViewController here. We're going to break it out into its own file, but I'm just getting this to work and basically get a minimal viable product and ensure that all these pieces fit and work together before we start to doing anything more fancy and refactor it after that. First thing that we need to do is pull out all of the Crags in our database. Now, we might have run this application a couple times before, so we might actually have some entities in there, but we need to check for that first. So I'm going to have a new fetch request, and that's going to be our object that we're going to construct in order to say, hey, I want to go grab Crags of a certain type. We'll get more complicated as we go in later videos, but for right now, we're just going to say Crag.fetchRequest, and this will pass back a fetch request generic of type Crag. So we'll select that, And then what we can do is we can start adding predicates and sort descriptors and all sorts of things. But again, we'll get more complex later on. So we just simply create a fetch request. All right, so the ambiguous use of fetch request is because it doesn't know what that is. So let's go ahead and make sure that we import our core data module. And then go down and we're going to implicitly put this as a fetch request here. You can put in, as I mentioned, this request here is a NSFetch request of type Crag. So NSFetch request, and then what we're going to do after that is we're going to try to pull those values out using the fetch request. So we can make this a little bit more explicit or exact in what we're trying to do, but we're just going to have a fetch results container, and that's going to equal the again, we're going to get the view, the context, the manage object context, and we set that to context. So from the context, we can say fetch, and it's going to accept, as you can see, a fetch request. And that fetch request is going to be the object that we defined up here. So paste and then control / to go to the next placeholder, paste that in, and we have a few things to do. What this error means is this fetch can actually throw an exception, so we want to handle that. So what we're going to do is wrap this in a do, and then we're going to catch any errors that or any exceptions that come out. And for this one, we're just going to just print out the error. Now this error variable, it doesn't just come from nothing. It will actually be a default value of our catch. And if we want a specific error, we can typecast this and pull out different error types and that sort of thing, because there's a lot of different exceptions that could be thrown by this fetch request. So because this line of code is the one that is going to throw the exception, we're going to try to do it. So we have to type in try right before that line of code. All right, and then it's just complaining that we've never used the results, and that's fine. What I'm going to do here, we're going to refactor this, but I'm going to create a variable for the fetch results, and those fetch results are going to be a array of type Crag. And I'm going to set that to, actually, let's do the preferred manner. So that's the generic. Let's do it that way, and then our initializer is just an empty square bracket. All right, so now we don't need to do a let on this because it'll use this value up here. All right, now finally, because hopefully we're getting some results out of our database and putting it into the fetch results, now we can populate our table view with actual results. So fetch result, or actually I should refactor this to be fetch results. So right click, refactor, hit the S at the end, and then rename it. I'll rename it in a few places. All right, so just be a little bit more clear. And then now, whenever we come up and it is asking for the name of the cell, instead of just typing in test, we're going to do fetch results, and then using the square bracket notation, we're going to get the index path.row. And basically what it's going to do is say, what is the first element that you're asking me for? We'll go and get that, and then on that it's going to return a Crag, because again our array is of type Crag, so all the elements in that array are going to be Crag, and those Crags have a name, which is a string, and we're just going to paste it in there. All right, so let's walk through this really quickly so we understand what's going on. First off, we're storing a local reference to our managed object context. We're creating a new Crag with a location. We're saving that to the database, and then we're fetching all the Crags from the database. So at first run, there should be one, storing that into the fetch results array. And then in our table view delegate methods and data source methods, actually these are just data source methods, we'll take the count of that. So right now there'll just be one, and then there'll be that'll display the name of this. Now on initial launch, you might not get results, but let's go ahead and test it and see what happens. All right, perfect. So we have new Crag location, and if we run this again with another one, so we'll put in another Crag location. We'll just keep all these other values the same. Go ahead and run it again. Now we have 2 objects in here. Now again, if I comment this out, command /, we still have 2 Crag locations. So I can quit out of this application, reload it, and this data will always be within that application. Now this is user created data, so what happens if you wanted to delete the data if you're just testing stuff out? Well, you can go back to the home screen, Command-Shift-H will go back to the home screen, as denoted with this thing here. So Shift, Command-H, and that will go ahead and put it back to the home screen. So click and hold, and then you can just delete the application. Get it done if you want to, and then if you relaunch the application, again, the new data is not being added. Now our table is blank, and we can go ahead and re-add that data. All right, so I think this is a good place to stop. In future videos, we will add in a default data set so that we can actually have data that is pre-populated in our application. We'll also be able to click on those Crags and create and view the list of routes within those Crags. So we'll create another ViewController. We'll click on that and then show details of that route. Be able to add photos to the route just like we had for our example here. So being able to add an image such as this, and then also getting the GPS location of the user so that as you approach this Crag, you know how far it is, how which direction it is, all that fun stuff, and really just dive down really deep and in a lot of detail for this application. So if you have any questions or you'd like to see the application go in a particular direction, let me know in the comments below. Jump on the Discord channel, which I'll link to in the description down below as well. And don't forget to subscribe to get notified of those future videos. Thanks, and we'll see you next time.